Hello, today I'll be discussing Lab 1 titled Charge Tapes. The purpose of this experiment is to observe, model, and analyze the properties of a charged piece of Scotch tape. Specifically, we're going to be analyzing the physics behind having one piece of charge tape float above another using the following fundamental principles: Newton's second law and the electric Coulomb force and its relation to the electric field of point charges. Here we have Newton's second law being defined as mass times acceleration, where in this lab we only have two forces acting on our piece of charged tape, that being the force of gravity and the electric force of one piece of tape on the other, where the electric force is equal to the electric field times the charge of the observed particle, and the electric field is the electric field of point charges, which is equal to the electric constant times the charge of the source particle all over r squared, where these Q's will be the same because the tapes have the same charge. At least we're assuming so. It's also important to note that we treat each piece of tape as a point charge in order to use these formulas. So by combining these concepts, we're able to accurately create a model reflecting the following observations. After creating the charged tape, we did a series of tests to get the properties being it's positively charged, as it was attracted to a negatively charged fin. They're attracted to neutral objects, and the two different pieces of tape will repel each other. We use that property when creating our experiment to collect data we use to calculate the approximate charge of the pieces of tape. So here we have the 2 point charges of the tape given by these dots separated by a distance d, where our system tape B is affected by the electric and gravitational force, or the electric force is given by the surrounding tape A. Here the tape is in static equilibrium, or in other words motionless. Acceleration is equal to 0, meaning that the magnitude of the forces must be equal to satisfy the equation. And by rearranging the equations we can get an equation for Q. We created the model using the same assumptions as addressed before in GlowScript. Here in GlowScript I first set the constants and initial conditions as described previously. Something new here is I got the length of the tape, converted it to meters, and used this ratio in order to find its mass, which was necessary when calculating the force of gravity, or the weight. Let's find the objects here, separated by their distance d. I have a function for the electric field, where we calculate the r vector given the arguments, and we can also calculate E as a vector, where it's returned here when creating the visual for the electric force, was equal to Q times the electric field. I also created a visual for the gravitational vector. Running the code, you see the gravitational vector in green, the electric vector in purple, where they're equal in magnitude as seen here, opposite in sign, and the charge piece of tape. The charge of the piece of tape is given here as well, based on the calculations. The calculated charge Q we found in the code is the charge of the tape needed for it to float above another piece of tape, given the force of gravity and distance d. We can divide that charge by a charge of an electron to get the electron efficiency, as seen here. Sorry about that. And then we can also get the number of atoms given the area of the piece of tape, giving us a ratio of 2001 for the electron efficiency. And to close things out, let's address these two questions. First, what if the sign of protons and electrons were reversed? In this case, the pieces of tape would still repel each other as they're the same charge, and we would still see an attraction to neutral objects for the pieces of tape, and then we'd still be able to find the sign of the charge by having a known charge, such as with a pin. And then for the second question, why is it important to handle the charge shapes as low as possible? And that's because charges can transfer through contact, meaning because the tape is electron deficient, when it interacts with another object of charges, such as your hand, or like a neutral object such as a book, some of those electrons could transfer to the tape, thus neutralizing its charge. And with that, thank you for watching. I hope you have a great day.